No, we're live. We're live, Malikeh.
Awesome. Hello, welcome to the episode 5 of the Small Language Model show. This is Malikeh, applied NLP Research Scientist at Arcee. From now on, I'll be co-hosting the show with Mark, Arcee CTO. So nature has always been a source of inspiration in science and technology, from mimicking the flight of birds to invent airplanes to solar panels inspired by photosynthesis and studying swarms for collective intelligence. So this time we're bringing this inspiration to AI by a new addition to MergeKit, which is Evolutionary Model Merging. Today we have Charles, owner of MergeKit, and Jacob, CTO of Arcee, on this show to introduce this groundbreaking method to the audience. So welcome to the show, everyone. Stage is yours, Charles. I would be thankful if you would start with a brief introduction about evolutionary model merging and what this approach brings to the field.
Sure, absolutely. So evolutionary model merging is a very cool approach that's been introduced by Sakana AI recently in a paper that they released. And essentially, it's an approach that uses genetic algorithms to optimize the parameters of merges to optimize for measurable qualities or skills or properties of language models.
Okay, awesome. So can you share some real-world examples or success story where evolutionary model merging has been applied in practice to create highly effective models?
Absolutely. So the example that they used in their paper was that they wanted to create a model that was able to answer grade school math problems, but in Japanese, but both taking the question in Japanese and then answering in Japanese, which that's not exactly a differentiable objective there, but by using these sort of genetic algorithm-based approach, they're able to say, okay, just check, are the characters in this response Japanese, and then is this response correct? And then they use that as their metric to optimize as these parameters, and they got a model that does really, really well at that task, which would not be an easy thing to do otherwise.
Awesome, sounds great. So in part of the paper, it is mentioned that this evolutionary model merging can be optimized for domain specific headlines. Can you explain more about this, like how it can be adapted to specific domains, like when it comes to new domain adaptation areas?
Sure. So the thing that's really nice about this approach is basically if you can measure how good a model is at something, then you can use that to guide this optimization process and get a model that's good at that as well as any other behaviors that you want to retain. So, for example, for their that math situation, they translated a part of the training set, I believe, of the GSM-8K set into Japanese, and then just plug that into the same evaluation code that's used for that benchmark, and then we're able to get Japanese math specific domain model there. The same thing applies to basically any domain that you can think of. If you come up with sort of some gold standard QA pairs, and not as many as you need for training, like orders of magnitude less than you need for training, then you can plug these into there. And if you have components that have some abilities in that domain, then they'll be blended together automatically to get you the best you can.
Yeah, awesome. Yeah, thanks for the clarification. So this is a question for everyone. So how do you see this evolutionary model merging different from the prior merging approaches we already have on MergeKit? What do you think this approach brings to the field?
Yeah, I think that's an awesome thing to maybe think and step back to how we got to the evolutionary model merge. So there was, the MergeKit YAML entry point into MergeKit where people were defining custom YAMLs on how to merge the parameters of two models. And there's a lot of different ways that you could go about doing that. And obviously, when you're working on a manual merge, you're kind of going through the process of iterating on different config YAMLs and checking results, which is sort of like checking against evals. And then the natural thing was to think about how can we automatically do this process. And it was pretty cool that Sakana produced the Evo merge on top of the normal YAML entry point to show that this was possible. And then sort of Charles is built from there to fulfill that need. I think the one other exciting element of that, though, is this is sort of the first approach that people have found for this the simulation, right? There's obviously different ways we can do this. I know some of the future questions I think are going to get into that, but exciting that we have it now.
Yeah, awesome. Congratulations. So yeah, I totally agree with the value this like approach brings to the field. So how easy it is to implement that? Like, is there any resource and tutorial so that people who are new to MergeKit or want to adapt this approach, use that to like apply Evolve model merging to create new foundation models?
Yeah, so in our release announcement of MergeKit Evolve, the script that we implemented for this, there is a little tutorial there which walks you through doing this for a basic task. Japanese Twitter actually, some people did some translations and some elaborations on that, which I found quite fun, better than the tutorial I wrote.
Okay, awesome. So yeah, I think if you check out the Arcee blog post, there is one in particular that we walk you through all the steps of applying evolutionary model merging. And yeah, I'm looking forward to new models coming out of this like approach. So yeah, it sounds great. So what kind of model architecture does like Evolve merging support? Is it like limited to specific architectures, or like is it model agnostic? Can you clarify this part more?
Absolutely. So this MergeKit Evolve script, it works with every model supported by MergeKit, which is basically most causal language models that are available in the Hugging Face Hub will work with it. It does need the models that you're merging to be from the same architecture. That's still a constraint, but anything that you can merge with MergeKit, you can use with this evolutionary approach.
Okay, sounds great. Yeah, actually, how do you see the like future directions of like using evolutionary model merging, or the future directions in general regarding like the MergeKit toolkit?
Yeah, so the method that I've implemented in MergeKit today is the parameter space method described in the Sakana AI paper. So they describe sort of three approaches. They've got parameter space where you're just changing the weights and the densities of the different models in your merge. Data flow space where it's actually the what people in the open source community call Frankenmerging, where you're just picking and choosing layers from different models and sort of assembling your own horrifying sandwich. And they've described a great way for using genetic algorithms to create recipes for that sort of merge in a much more like controllable, predictable way, creating models that perform well and don't have some of the misbehavior that you often see in that sort of merge. So that's a thing that I'm excited about. They've shown good success with that, and that's going to come to MergeKit sooner rather than later. And the third approach that they implemented is the combination of the two, where you're simultaneously doing the parameter space and then the depth flow space merging. So that's also coming.
Yeah, awesome, great. So this might be more relevant to Mark. So regarding the because like domain adaptation is a challenge these days, and how do you see evolutionary model merging would bring a value to business, like how it can be applied to actually do this domain adaptation and help with addressing these challenges we have in terms of like benchmarkings and also like many different like challenges that you're familiar with?
Yeah, I mean, I look at the way I see it, evolutionary model merging is kind of the bigger step in the world of merging, right? You have your base merging, evolutionary model merging takes, base merging a step further. I see overall merging as the next wave of transfer learning from within Gen AI, right? So, how does that translate into the business world? I think that, whenever you have the ability to do, transfer learning and bring in other great open source checkpoints into your model, it can be extremely beneficial from a business perspective. That's why I've said over and over that I see that the true value in model merging is actually pairing it with your own pre-trained model, right? So it's taking a domain model. You've done some kind of fine-tuning pre-training on that model. It is now domain aware about your data. Now doing a merge and bringing in other great knowledge bases, let's call them, from other models and merging it into your model, right? I think that's the true value. And then, when you unlock transfer learning in the world of LLMs like that, that's massive for the business world.
Yeah, awesome. Jacob, do you have any further thoughts on it?
Yeah, I definitely fully agree with Mark that the problem of solving, catastrophic forgetting in the world of training LLMs. And the nice thing about this too is everyone already has these trained LLM checkpoints in their their enterprise work that they've been starting to work on already. Maybe they've been fine-tuning, maybe they've even stepped back to continuous pre-training. And they're getting some results, and merging is a really great way to recover the general intelligence from the general chat checkpoint. The thing about Evo merging that is especially exciting within enterprise applications and just all applications, period, is what are the emergent properties that emerge from the Evo merge when optimized against different tasks. And I think this is really interesting, right? Because it's knowledge pooling between two separate and disparate sources, like the vision language model in Japanese, right? It's this whole different conceptualization that the Japanese have of the physical world around them is being merged in with the way that people in the English-speaking world see those objects, and that leads to all kinds of interesting combinations of things that it's difficult to think about just from a config standpoint. But I think it also remains to be seen a little bit. Like this cat is just freshly out of the bag. When did you merge the PR, Charles? Like 2 or 4 weeks ago?
Not more than a month.
Yeah, not more than a month. So still to be seen. Certainly for us at Arcee, what we're seeing empirically with the enterprise customers that we're working with is we're seeing some of the best results of our merges coming out of Evo merges. And those are still also early days of results, but a lot of practical scenarios can be applied by having the two open-ended entry points of number of checkpoints and number of eval tasks. And there, right, the world is our oyster from there to see what will emerge from there.
Yeah, totally agree. Like, I think it was an interview with Sarah Hooker, like from last year, I guess, and like she was in particular mentioning that like it's really hard sometimes to like so in like when it comes to machine learning models, we sometimes have very like similar predefined like loss functions to optimize for those, and like when it comes to specific domains and when it comes to specific headlines for optimization, it's really interesting that Evolve merging unlocks this thing to do it for domain specific like benchmarks and to adapt a specific like data sets, and we do it within the field, and like it puts your hands open to what headline to optimize for, because like when it comes to domain per domain, it's not all the time to like just keep an eye on like a very specific loss function and just optimize for that headline. And like there are many different perspectives that should be captured, and I think like Evolve merging, it's really like unlocking this part. Yeah, sounds great. So like regarding the like applied sort of scenario of how to use Evolve merging, it would be great if we do a like live demo and like show the audience of how we can apply it in practice. So yeah, I'll ask Jacob to share a screen or maybe show a demo of like Evolve merging application.
Yeah, sure. So fortunately enough, we have 8 H100s ready here running in the Arcee cloud, which we'll be able to run an Evolve merge on. I'll start off by just kind of presenting the docs, and I'll kind of show you how you can do this right on your own GPUs. You can run this on an A10 GPU. You could run this on Colab. In the spirit of MergeKit, right? We want everybody to be able to run these routines. So I'll go ahead and share the README first. So here you can see in the MergeKit docs, you have the evolve.md, which is where you have docs on how to utilize MergeKit Evolve. So as normal, you'll install MergeKit. There's a little catch with flash attention. You might want to uninstall and install that again. And then here's what the general entry point looks like into Evolve merging, which is to provide your list of models that you want to merge, and then the merge method. Now, you need to make sure these are of the same base model. So make sure you're merging the same family of Mistral models or Llama models. And then from there, you also provide the task entry point. This is where you're providing eval tasks from the LM eval harness, which you can see if in their tasks of LM tasks in the LM eval harness. And I guess from there, I might pass it to Charles to talk a little bit about the other configurable parameters in here, and then we'll go ahead and dive in and actually run one of these.
Sure. So the parameters here are configuring basically what sort of merges it will be optimizing for. You have to decide what method you want to use, and that's That's most of the methods implemented in MergeKit today. I think actually there was one introduced after I merged this PR that I haven't brought it in there yet. I'll fix that. But if you choose your merge method, you put in your base model, and then there are some options in terms of how fine grained you want the parameterization of this merge to be. So there's this layer granularity parameter, which you can set to specify that, okay, I want to have different weight values for every group of 8 layers in the model, for example. And then this is offering sort of a trade-off between expressivity of the parameter space that you're optimizing in and runtime. This, the smaller the parameter space that you're optimizing, obviously the easier an optimization it's going to be. You might not necessarily get as good a result, but you'll get it much faster. And then normalize is same as in standard MergeKit. It's whether you're constraining things to keeping the same magnitude of weight as your input models. Allow negative weights is basically this is for task arithmetic and its whole family tree of merge methods. So DARE and ties and model breadcrumbs. Basically, applying negative weights doesn't make sense for most of the other merge methods, so they'll not be they'll be taking the absolute value of internally. If you have this flag not set, with that set to true, it'll let you get to some of the the larger explorable region of the parameter space that you can get to with those methods. And so, like Jacob mentioned, it does use the LM eval harness from Luther AI for the backends. Put in some tiny guardrails to encourage people to not just directly optimize against the OpenLM leaderboard there, but basically any task supported by that you can use. And there's also, it is quite straightforward to write your own task. For example, if you have a set of QA pairs that you want to optimize against the accuracy of, it's easy to write a YAML configuration file for the LM evaluation harness and get it running in this. Anything else I should cover there, Jacob?
I guess maybe before we launch it, well, actually, no, we could talk a little bit about how it's working after we launch it. So
Sure.
I'll go ahead and dive into that. Or Mark, do you have a question?
Yeah, I just wanted to say, as Jacob chose this, and Charles talks about this, obviously it's apparent that you need GPUs to run this, right? And as Jacob mentioned at the top, this is a cluster of H100s that we have running. So, little hints, Arcee Cloud is something that we will be delivering evolutionary model merging as a service, which we'll be launching very soon. We will be providing more information on that in the next day or so. But we understand that GPUs are hard to come by, and you don't necessarily want to have a whole farm of GPUs yourself. So we will be providing that as a service as well to enable anybody to log into our platform and do evolutionary model merging.
Yeah, Mark, that's a great point. We are working on infrastructure behind this as well, which will run in pretty much a similar method to what we're showing you here today. And of course, yeah, the GPU clusters are always good for evo merging, as you can run as many simulations as you possibly can, and it always gets better. So that's a nice element of it. So now I'll go ahead and dive in here into actually a live terminal for this. I'll go ahead and share here. So here you can see I'm cloned into MergeKit. I'm inside of the MergeKit folder, and I've run some of those install commands from the README here, and I've defined a config YAML. So let's take a look at the config YAML that I have here. So here I'm merging a couple of models. I'm merging into the column instruct model, which is a Mistral model, Mistral V0.1, and it's basically been tuned for chat, kind of like the normal chat models that you use for that. And in here, I'm merging into a CPT checkpoint from Solawetz, which is a research project Malikeh was looking into of the Sol authors who did legal pre-training. So basically, I'm trying to inject some legal pre-training knowledge into Column. I could eval against other tasks, but I've chosen to eval against the AGI eval and truthful QA. Of course, here, right, the world's your oyster. You can stack those up. We will say, the more evals you stack up there, the much longer this is going to take to run, as that's a big rate limiter on your different simulations of merges that you're going to be running. But so now I can go ahead and just kick this off. So here I have MergeKit evolve. I'm going to run 1,000 eval iterations of different families of these models that merges that are occurring. And I'm going to launch this on WanDB so I can monitor it. And let's see, I also understand the depths of the evils that I'm unleashing and that I'm optimizing against Truthful QA and AGI eval, which are on the LM leaderboard. But as long as I'm not going to hack the leaderboard with this, I think that's admissible. So there you go. You can see I'm already logged into WanDB. I also had to log into Hugging Face as I am using the Mistral weights, and you still need to approve that now. And then you can see here, it starts to launch. So here, Charles, I think maybe you could kick in and talk a little bit about what's occurring here.
Well, sure. So, it's download all those models and store them on a disk. And now basically it's coming up with a bunch of different genotypes to evaluate, where it's basically just a different set of parameters for the merge that you define. So it's using the Dertize method. So there's a density associated with each task vector and also a weight. And basically it's just shoving a bunch of random numbers in there, creating a merge config from that. And then it's going to start evaluating those tasks that you mentioned and coming up with what scores each of these resulting models get. And then from those scores, it's going to be able to estimate sort of the where it thinks that the maximum is relative to sort of the average. I'm not going to describe the CMA algorithm, but
yeah.
Yes.
Content for future study if you'd like to look into the CMA algorithm.
Yeah, so it's going to run those evals, get those scores, and then based on the scores of this, this generation of genotypes, it's going to come up with some new candidates to evaluate. And it's just going to keep doing that basically for as long as that number of evaluations that you set there. And throughout this process, it's going to be tracking whatever merge config got the best possible set of scores, the best set of scores seen so far. It's going to be tracking that merge config and those scores, and then keeping those logged to weights and biases. Yeah, looks like it's running evals now.
Yeah, so this is almost this feels kind of like a training routine in some respects to me. So like any training routine, it's kind of fun to watch your evals go up. You can monitor, you can let this run for longer, and then at the end you get a merge. It will actually perform the merge for you. So you get your final merge auto merged for you, and then from there you're off to the races. So I think I'll go ahead and stop sharing here. And that was a good little tutorial into using the merge evolve. So it's out there, open source under our GPL license. So you can find it there.
Okay, awesome. Thanks for the demo, Jacob. So Charles, you said if you have your own Q&A data set, you can add it via this LM harness thing. So is there other than GPU resources which are needed in terms of the data set, how big this data set should be to do this optimization first? So yep.
Sure. So it's very flexible. I mean, you could do something with as few as 50 question answer pairs. I would aim for more like a couple hundred, but honestly, you don't need more than that.
Awesome, sounds great. Yeah, thank you for the demo and thank you for the fantastic conversation. So our model merging hackathon ended this week and we got lots of submissions. Our judges, Mark and Charles, will be reviewing those and we should be announcing the results within 2 weeks at our next show. So looking forward to it. Now we're getting close to the end of the show. Thanks everyone for joining. Sorry if we missed any questions or comments. We will follow up with you offline. Hope you all enjoyed the show and we'll continue these shows every 2 weeks. Just as a wrap up, I just want to look into the comments and check with the backstage to see if there is any comments that we didn't answer.
Maybe, but just before we go, we got 2 minutes. Maybe Charles, if you want to give a shout out to the Noose model that was just released today, which is extremely great model.
Absolutely, yeah. So about half an hour ago, actually, we released in collaboration with News Research a merged and then further trained model. It's a combination of their Hermes 2 Pro model trained on top of Llama 3, the 8 billion parameter model, and then merged with the official Instruct model, which is still kind of the best there is in terms of trained models. And then ran DBO on top of that to get something that's actually kind of the best of both worlds. It maintains all of the function calling and structured output capabilities of the News Hermes Pro model, while getting some of the frankly upsettingly good instruction following of the official Instruct model. So check it out. Another great release with News. It was fantastic to work with them.
Cool. And we'll put the model in the chat, the link to the model on the Hugging Face Hub in the chat.
Awesome. There's just one question left for Charles. Like, can you clarify more the difference between like parameter space and like data flow space? Because these are the two main like building blocks there, and people sometimes are confused between the like differences.
Absolutely, yeah. So parameter space is sort of your more standard merging, like the sort that if you read any research paper on merging, they're doing parameter space merging, where you've got your two sets of weights between your two models, and basically you're applying some sort of interpolation between them for each of these parameters, and then maybe there's different weights and stuff, but it's a one-to-one mapping of, you've got this model, this layer merges with this layer, and you're just changing the parameters of how that sort of merge is done. Versus the data flow approach that they came up with is you're actually sort of picking and choosing different layers from different models. So maybe you have layer 1 of model A, layer 2 of model A, layer 3 of model B, so forth, so on. And it doesn't necessarily have to go in order like that. So an example of the sort of merge that this is able to do is if you look at Goliath, for example, which is a very popular Franken merge. It's a 120 billion parameter model that was created out of two different Llama 70B models. That sort of thing, where you're actually interleaving different blocks of layers and duplicating layer indices. Hopefully that's helpful and not actually just more confusing.
Yeah, great. Thanks for clarification. So the link to this model is also shared in chat, like the News Research Hermes 2 Theta, like Llama 3 8B. And also before that, we also shared the link to that blog post that walk you through the steps to do evolutionary model merging. Again, thanks everyone for joining the show. Hope you enjoyed this. See you in the next 2 weeks. Thanks, Charles, Mark, and Jacob for this fantastic conversation. Thank you.
Thanks.
Thanks, everyone.